Hello all. In this tutorial, we'll continue our part of coupled Eulerian-Lagrangian slope failure visualization. So we'll start with whatever we have done in our ABAQUS Python script. So we'll just directly run to the part which we have done till yet. So you can see in the script we have done the creation of step and contact property using interaction, which is rough interaction. So we can just go out and check till the interaction. Yeah, it's created. Now what we are going to do is a bit complex. So I will go a bit back into our part module, which is the top part. So here I want to create a partition where I can assign the Eulerian part. So initially, because this is a completely Eulerian part, but we need to define where the part which will start flowing will exist. So we have to create a partition. So we'll go to the part module, and yeah, we have to go to top part, and from here we'll start recording our macro. We'll go to macro manager, we'll create a macro, and we'll use a working directory, and dismiss this part. Now what we'll do is that we'll create a sketch on this face. We'll specify our origin to with this point. Let me just zoom in a bit so that so let's click on done, and yeah, this is the origin. The face which will be vertically and right will be this. So yeah, that's our sketch. Now we'll insert the sketch from sketch module, which is one of the middle sketch, named as middle sketch. So it is exactly situated where we want it, and we'll click on done. So we have these 2 points already with us. Now we need to create a third point where we are going to insert the Eulerian part. So bear with me in this sketch. So what I am going to do is that I am going to create a zone where Eulerian part will exist. So yeah, this will be the zone. So where my cursor is, the enclosed part around my cursor will be the zone where Eulerian part will exist, and will remove all other lines like this. So what we are going to do is, just to make it a bit simple, we'll remove the enclosure, and we'll just we'll remove the enclosure, and yeah, so like that. Now what we are going to do is that we will now again create enclosure using these points, and now remove the outside lines which are connecting the enclosure. Now you will know after I have finished the sketch why I have done this. So this is the enclosure which we wanted to create. Now I will just click on cancel and click on done, and yeah, I guess this is it. But before doing anything, I will just create the partition as well. So I will use partition cell using extrude or sweep edges. So I'm going to select this, and I'll click on shift this and this as well, and I'll click on done, and I will sweep along edge. So this edge I will select, because across this direction I want to create a partition. So I want to create the partition on both the sides. So you can see here on the other side the partition is not present. You can see slightly, you can see that on the other side the partition is not there. So I'm just going to click on create partition, and yeah, you can see now on the other side the partition has been activated. Yeah, here and this. So it looks like the eye of some rectangular bird whose face is rectangular. But yeah, now we'll stop recording, and we'll go on to our Python script, and we'll edit this macro and insert it in our main file. So till here we don't have anything, but here we have these 3 lines. You can now start judging by looking into the lines. The 3 points which we connected were 10, 10, 20, 10, and this 3 lines. So I'm just going to remove this line, and these are the points which I am going to remove. This again will not be required, and we'll keep on removing all these lines. Will not even require the inclusion of sketch. Yeah, so project reference onto sketch, sketch S coplanar. Yeah, so we'll remove this lines, make sketch transform. Yeah, this is what we are going to do. And S will be the model constraint sketch name, and what will be the S? Are we using S anywhere? Yes, grid spacing. So no, this is a general sketch, so we don't require to create this. So let's just go with this like that on, like very similarly, FED. And yeah, set primary object option superimpose. I guess this yeah, this will be required line for now. P top part will again not be required, and yeah, these lines are required. So we have created a sketch. Maybe later on we can simplify this a bit, but for right now I think these are the lines which we will be requiring in our main file. So I'm going to cut these lines and I'm going to paste these lines here, and I'm going to click on shift tab. Now these are the lines which were gone. Now we'll remove the session object lines as well, not required. Session lines not required. Yeah, and delete sketch profile. Well, yeah, maybe not required, or you can just have something like this here. So we can create a constraint sketch again here with the name of similar sheet size, and we can like, but anyway we don't require, but we'll just edit this here. Partition face by sketch, and we picked the sketch as set primary object, and yeah, partition cell by sweep edge. So I guess these things are not required. F is equal to p dot faces, so I'm just going to cut this and paste it here, and I'm going to remove this and E1 D1. Yeah, partition face by sketch. So this sketch creation and partition P face by sketch are completed till here. So yeah, this is where we finished our partitioning strategy. So we can again remove this P part. So this is redundant, so anyway we don't require it. And deletion of profile sketch, so maybe we can name it as temporary partition. Yeah, so anyway it's assigned in the name. D is not required. P dot edges. Yeah, so yeah, now after this we can again remove this line. We can cut this line and move it here, and p dot edges. So E is equal to p dot edges, so I'm going to control Z. Yeah, p dot edges. So P is already defined, so no worries. C is control X. Yeah, so picked edges. Yeah, these lines are required for the creation of partitioning. So I'm going to cut it and paste them here, and put shift tab and save them, and I'll close this macro file without saving any changes. And I'm going to clean the slate and just to check if whatever we have done is correct or not. So I'm not going to go with just don't save a database, and I'm going to run the script which is CL. So I have to check my part, which is the top part. Yeah, and see if this partition strategy has been successful. Yeah, this partition strategy has been successful. So what we are going to do now is that we, after creating this partition, will move on to the next part of our exercise, where we have to define the material properties of this section. So maybe we'll go to top part again and we'll create sets. So first of all we need to create a geometrical set. We'll call it wedge, because this is a wedge which will be failing. And maybe before doing anything, we'll just again start with a macro. We'll go to macro manager, we'll delete this macro, and we'll create another macro in the working directory. Now what we'll do is that we'll go and create a set, and we'll call it wedge. We'll click on continue and we'll select this edge, this set, and click on done. Now this is the set creation. I guess we have also left out the section assignment of the Eulerian part, so I'll just do it right here. So I'm going to create a section assignment for the whole part. Now this is called a set 2, but we can rename it as set 1 later on. So we don't have any Eulerian section, so we have to create a Eulerian section. We'll call it EUL section, but the basic material behind the Eulerian section will be soil only. So yeah, we'll just click on OK with soil and we'll click on OK. Yeah, so that's what we have done. Now we'll stop recording and again we'll look into the macro. Let's go and open the macro file. Yeah, and we'll just copy everything because it's very small code, and paste it under this line, and we'll again use the shift tab strategy. We'll remove this redundant lines, cut, paste, and again we are using top part only, so we don't require this line as well. p.cell name wedge, session viewports we don't require, so maybe just get away with them. Model EUL section, we can create the EUL section very similarly. Top part P, again we don't require it. C is equal to p.cell, so we can directly cut and paste them here, and we can remove this line as well. And yeah, this is a bit complex, not complex but a big line. So section assignment is pretty general. We'll have EUL section and we have assigned it to the part. So what you can do is you can go back up where we have created a Eulerian section out of the name Eulerian, and we have assigned this here. So yeah, that way you can also do it, but I suggest we just keep this here for the purpose of our execution. So we'll keep together the Eulerian section creation and Eulerian section assignment. We'll just save this and we'll clean the slate again. We'll go to file and we'll clean the slate. Yeah, and we'll just run the script and see if it has any error or not. I guess it's taking some time, but I think the properties has been assigned to the Eulerian part as well. So I'm just going to give it a brief check to the top part if the section assignment has been done properly. Yeah, the section assignment has been done and the set name is set2, so we can change it in our Python file to set1. You can basically go here and change it to set1, and that's it. I guess we don't have to do much. So in this part, I guess we'll just do only this part. We'll create a section assignment of the Eulerian part, and in the next part we'll continue with the boundary condition and actual analysis maybe, or if it required I can do one more part. So thank you.